Good morning. My name is Frankwell. I am Chairman and the CEO of Andes Technology Corporation, also Board Director of RISC-V International Association. Today I'm so glad to be here with you to share my point on HAI, HPC, Automotive SoC by RISC-V. Well, since this is IP SoC Day, Silicon Valley Conference, we are talking about IP SoC. So my point is from RISC-V CPU IP to SoC with this application. Let me share my points with you. First, let's talk about edge computing use cases. In the slide, you can see from smart street lights, AI-powered AGV, face recognition, to robotics overall inspection. With AI embedded in these application-based SoCs, the quality, the intelligence, and the effectiveness, the efficiency can all be improved. The position of a CPU it plays, the key values a CPU provided that can empower the edge application includes energy efficiency, security, safety, and certainly the most of all, machine learning, artificial intelligence that combined with developers' experiences. Now, for high performance computing, one important index comes from the computing power stacks. How do we estimate how able the machine itself or chip itself that can contribute to high performance computing? From Wikipedia, that top 500 supercomputer database, we observed that since last century to this century, since the last decade to this decade, we can see a steady growth of computing power from academy as well as industry. So the index comes from the flops itself, per second floating point operations. Today, in this decade, it's already in the region of 100,000 T-flops, which we call the T-flops. Such a computing power will help to manage large scale and dynamic range data supercomputing, or say high performance computing. Other than flops, T-flops, there's also another index which we call it TOPS, T-O-P-S, G-O-P-S, M-O-P-S. Anyway, the number of per second operations in computing. So different kind of application requires different kinds of computing power, from a smart camera, smart home, mobile AR/VR, surveillance. These are all called HAI. To automotive, data center, and HPC high performance computing. In the bottom, you can see tens, hundreds of GOPS or TOPS are required day by day. So today, similar to the index of T-flops, 100,000 TOPS is required for today's application in high performance, or 10 TOPS, tens of TOPS required for automotive application, and at least several TOPS of the computing power is required for HAI application. In the right side of the slide, I started to mention the series of RISC-V CPU IP provided by Andes. Different series that comes with different performance region and combination of power, performance, area code, and area factors that available for different range of applications. Today, in this presentation, I'm going to mention a few RISC-V CPU IP provided by Andes that can contribute to the applications we mentioned today. HAI, high performance computing, and automotive. For edge AI application, D45 will be mentioned. For high-performance computing, AX45MP, NX27V, the combination will be presented. And for automotive-grade application, N25F-SE will be mentioned later. In this slide, let me introduce A45MP or AX45MP. The difference between them is A45MP is a 32-bit core, while AX45MP is 64-bit core. In this multi-core CPU IP, it supports a 1 to 4 32-bit or 64-bit CPUs with RISC-V GCMP ISA modules and NDIS V5 extensions. It also supports SMP Linux. The bus interfaces, we have a local memory slave port, coherent slave port, AXI bus master interface. Also, the interrupt mechanism is a PLIC. The coherence itself, we follow Macy cache coherence protocol. The I/O coherence for cacherless masters. Each core comes with optional level 2 cache controller with a size from 128 kilobyte to 2 megabyte. The line size is 64 byte. To apply AX45MP in high-performance computing, why high frequency is required? Not only 5 nanometers, 7 nanometers also makes sense for high frequency generation. We also tried leveraging the process library provided by TSMC, 7 nanometers. So the frequency can be 1.57 gigahertz in TSMC 7 nanometers. And again, for 5 nanometers, it is 1.74 gigahertz. So we conclude that certainly deeper nanometers process can generate a higher frequency chip. Higher frequency core will bring higher TOPS or T-flops. So that means when higher frequency can be applied, then higher computing power can be generated. Now, I'd like to introduce another core, which is NX27V, a vector processor. It is the first RISC-V commercial vector core available to the world in 2020. And till now, we already support the latest spec, V1.0, which was just ratified. The RISC-V vector data formats are supported. Also, the supported data format includes extended bfloat 16 and int4. It comes with an efficient scalar unit and powerful vector unit. The block diagram is set here for reference. The RISC-V vector instruction starts execution after retard, and it comes with multiple functional units managed by vector instruction queue to have parallel, channelable, and mostly fully pipelined vector instruction issuing and execution. The VLAN and the SIMD widths are quite powerful. As far as we understand, so far it is the most powerful vector processor for RISC-V that comes with 128-bit, 256 and 512 bits VLAN and SIMD. The performance data comes with NX27V is presented here. You know, the configuration of a different combination of VLAN and SIMD are many, but I choose 3 of them to present here: 256, 256, 512, 256, and 512 and 512. The maximum frequency in worst case can be higher than 1.2 gigahertz for TSMC 7 nanometers. And the gig count is from 1.7 million to 2.6 million, which obviously for 1.7 million gig counts, it is for 250, 256 VLAN SIMD configuration, while the 2.6 million gig counts is for 512 bits VLAN and SIMD configuration. And the dynamic power is small, it's less than 18 microwatt per megahertz. So I like to combine the data provided for AX45MP and NX27V to tell you the story of building blocks for high performance computing because of the computing power that can be stacked. AX45MP, as we mentioned, from one core that can be configured to 4 cores SMP multi-core running at 1 GHz. AX45MP 4 core can deliver up to 64 GIGAOPS. Why is that? Each single core can operate 8 by 8 multiply and accumulate RISC-V instructions, while multiply and accumulate are counted as 2 ops. So it can deliver up to 16 GOPS at 1 GHz. That's for AX45MP part. Now for NX27V part. Running at 1 GHz, it can deliver 320 GOPS and 96 G-flops. That is running at 1 GHz at 7 nanometers. Comparably, when running same core in 5 nanometers, it can up speed with a higher frequency. So NX27V in 5 nanometers can contribute the G flops from 96 to 110. Also, with the combination of AX45MP and NX27V, the stack of the computing power is kind of aiding them together. So we can conclude that higher frequency, higher GOPS and G-flops can be captured, and we can leverage that for HPC design. And this is a application of combining NX27V, AX45MP for HPC example. The base is kind of PE, the processing element for CNN algorithm that in one cluster you design NX27V as a vector processor, AX45MP as its scalar, and combining the PE in a cluster and multiple the PE for deeper machine learning algorithm. So with the base for AI algorithm computing, we can reuse clusters that can minimize the risk of different design. And it is easier to debug, and it is easier to program. And certainly it is easier to apply the most famous AI's algorithm such as CNN. So the combination we suggest the designers that can leverage to design for HPC SoC is the combination of AX45MP and NX27V. Now back to HAI. As I mentioned earlier, I'm going to mention the core of Andes D45. It is a 45 series RISC-V core that come with DSP and the floating point processor. So the key value I like to mention for D45 is for HAI, the value contributed for computing, machine learning, and domain-specific application. The core can achieve 80% higher total DMIPS and 15% energy saving over competitors' CPU. And Andes also support ANDLA that can help to accelerate a convolutional kernel by 360 times and still remain tiny area. And for a domain-specific application or domain-specific architecture, we help to bring NDIS custom extension that can help engineer do custom instruction aiding. So that is a potential release for a domain-specific architecture. The AI tool, the software development tool, are available for NDSite, TFL, ITE, Micro. And for secure processing, we also leverage RISC-V TEE to provide application isolation between multiple secure processing environments. Then we also provide software libraries that can help optimize HAI application by DSP, by NN, and vector libraries. So by applying such software libraries optimized for AI, D45 can achieve 160% of DSP performance and 308% NN performance over competitors' delivery. In this page, I like to present the AI software stack and ecosystem NDIS cooperate with third parties. All these third parties listed here for your reference, they contribute from the high-level AI application, AI frameworks, model formats, model optimizations, and inference engines, signal and data processing, so that all the infrastructure built from bottom by NDIS, such as the RISC-V cores, N series, D series, A series, and the V series, can be supported. NDIS itself also provides NDISoft DSP library, as I mentioned earlier, and NDISoft vector library, NDISoft NN library, together with NDISoft LLVM compiler and NDISoft OpenCL as the total software stack and ecosystem factors that when design a chip of HAI application, the software part can be leveraged. Now I'd like to go over the third part of this presentation, which is functional safety certified RISC-V automotive solutions. The idea is to develop a safety design, but first we set the goal for safety goals. Then from that we derive functional safety requirements and technical safety requirements. We derive hardware safety requirements to generate safety features, to generate a safety design. We all know that for automotive, safety is the most important thing. So NDIS put a lot of investment in design flow and the product development for automotive grade products. I am glad to make announcement that in first half of this year, second quarter, NDIS will launch ISO 26262 SLB certified RISC-V core, which is our first product offering. This core is a RISC-V instruction set compliant. It comes with floating point processor as well. The SE means safety enhanced. So it is a product upgraded from N25F, the mature CPU core used by many licenses. As far as we know, N25F is the most welcome RISC-V core available in the world. It is 32-bit, 5-stage pipelined CPU architecture with a single or double-digit precision floating point processor. It comes with ECC code and data memory protection. It comes with physical memory protection. It comes with code dense, code size reduction mechanism. The safety features designed in also included in N25F SE for ECC memory protection. The mechanism of seconded single error correction, double error detection protection against data corruption. The ECC DMR for latent fault prevention for memories is designed in. For physical memory protection, we impose the privilege and access rules on software. For stack safe, it has been long-term designed in and these other processors. So as well as this one, it is for automatic detection of a stack overflow. Then the bus itself for a trap status bus, the trap status for further fault handling. So the safety package delivered, there will be quite valuable safety manual and the safety analysis reports together with the package. This product is an international certified company, certified for functional safety usage. Let me keep it still confidential for a safety manual and the safety analysis reports because they are the deliverables of the license agreements. So if signed, then they will be delivered. Currently, there are several beta site customers leveraging this core to design their chip while they are waiting for a certificate. The application includes a radar, LiDAR for vehicle. Also, there is automotive MCU under design, and there is TDDI driver integration under design. They are all for vehicle application. So let me make a conclusion as HAI, HPC, and automotive grade SoC are emerging and important application. And this keeps delivering innovative solution of a CPU IP to be embedded in SoC that can boost these applications. So the performance, the frequency can be higher, at the same time the power can be less. So it is our recommendation, and we believe that is a bright way for decision makers to adopt these cores in the application mentioned. And once again, we are glad that Andes will launch its first automotive grade CPU IP for RISC-V industry in second quarter. Thank you. This is my presentation for today.